Hey, Programming 12, we're going to make the character walk around. I said I was going to do the Goombas and enemies and stuff, but I had too much fun doing this, so I thought we would do it. We're going to have to do a few things to our F player class to make this work, but it should be good. You'll see right now it's going to fail pretty good. Watch the walk. Oh, Mario. No, he fell over. It's so goofy. I love it. I can't even, like, whoa. So first thing to note, we got to make this not rotate. F-boxes in general rotate. Oh, I'm back. But we're not going to. And then we got all this stuff to do with costumes to make the character look pretty fun. Oof. I just can't get, oh my gosh, I just can't get enough of that. Oh, he's fallen into the abyss. Okay, so first off, I'm going to recommend heading on over to your F player, and you're going to want to be setting rotatable to false. And that means that it just will not rotate, and you will, have a character that behaves properly. And then you're going to want to go and grab the costumes. Costumes? That's kind of a scratch way of saying it. You're going to want to grab the images from the sprite sheet that represent sort of the different frames of animation for the different actions. You can get that on Teams or Spriter's resource if you want to find different character other than the old school NES Super Mario Brothers. Yes. Sprite from the original Mario with the brown and red scheme. That's not, how he currently looks. But nonetheless, you'll want to grab those pictures, drop them in, and just to confirm, I have mine right here. There's the run, and actually, it turns out there's only going to be one set. This is from an older video where I didn't actually like having two different ones. So just one set of runs. There's two idols and a jump costume, and they're all facing in one direction. So we'll have to solve that later on. But before we get there, we're going to go and load all those things into arrays. We're going to have a different array of P images for each set of frames that comprise one action. So we'll take a look and see, hey, check this out. We have idle, jump, and run. So these are going to be my P image arrays, and they will store those, the like animations. Images, whatever. And then there's this fourth one called action. So action actually is going to be a very important part of the puzzle. So we'll try to explain it as we go. Basically, action, we're not going to load any images into it. It's just going to function as sort of a doppelganger that will, be pointed to idle or jump or run whenever we want to do a particular action. So we can set action to one of these, and then we always just animate action. We have to decide which one of these we animate. We'll just always animate this one and point it to the right one when the character is moving in the, whatever sequence we need. Okay, so next thing is just to load all those images, and that's pretty straightforward. I just do that in my load images. So I will just make idle be an array with two elements, and I just load them manually. You could do it in a loop, especially if you are doing a different sprite sheet. Loop might be good if you have more than three. That's fine. And then of course we have the jump, and the jump is just one image, and you might be like, why do we need an array for just one image? And it's just because then it's consistent with the others, so that we can use that action array to point to the different arrays. So nothing too fancy. And then we have the run. And then last but not least, we have action. And notice action, we never loaded any images into it. We can just point it to idle or jump or run, and then animate action. Whatever action we're pointing to, that's what we'll see on the screen. All right, so the next step is going to be going over to F player and seeing what needs to happen in there. All right, so here we are over in F player. And F player, of course, we already talked about setting rotatable to false, in addition to other things we've done before. And here's how it's going to look a little different. I'm going to add into the act function, in addition to, this used to be called handle input and handle collisions. I got kind of tired of handle. So input and collisions. We're also going to have an animate function. And animate is going to animate the action array, which, as you know, points to one of the other arrays. So it doesn't have its own separate pictures. And so here's what I'm doing. This is straight out of our animated GIF type of code. So here I'm just checking to see if we've gotten to the end, and if we have, we're going to set frame to 0. Notice though that I'm not just checking to see if I'm at the end, I also check to see if I'm beyond the end by any number of, it could be 100 beyond the end. And the reason is because action will switch from one array to the next. So in one frame I might be on going to the third image in an array of 3 images, and then I just jump and I'm now all of a sudden at 0 images, so length 1, or sorry, 1 image which is length 1. So 3 is greater than 1 by a margin, right? So I'm gonna not just check if I'm at the end, but check in case I'm well beyond the end, because action might change from one array to the next, and it might be different lengths. And I'll do that first, just to make sure I don't have an array out of bounds. And then here's our standard sort of code we've been doing from animated GIFs and so on. So, I just chose a rate here of 5. So every 5th frame, I will attach an image from that array, and then I'll increment this frame variable. And so the next time I do this, I'll attach the next frame. And of course, if I go beyond the bounds of the array, I get, if it's, whatever it is, I'll set it back to 0 again the next time I come around to this. So there we go. That's me animating action, basically action, always attaching from action. And then in input, we just have to attach the correct array to action. So for example, I've made things a little bit different. But here I have, if I press the A key, I set action to run. And if I press the D key, I also set action to run. Those are left and right. We'll talk about how to flip it in a little bit. If I press the W key, I don't do anything with jump. It's just when I am moving vertically or any kind of vertical movement, I guess, then I set action to jump. And I've just kind of picked a number out of thin air, and probably need to test this a little bit more. But I just say, like, if Vy, which is my y velocity, is either greater than 0.1 or less than negative 0.1, then I'm going to say my action is jump. And I do this at the end to override the run, because when I'm running in air, like, I don't want to see the legs and arms moving, right? That's not what the jump looks like for Mario. He doesn't walk in the air. So I'm purposely using ifs instead of if else's, and that way this can override other actions when I am falling or jumping. Last but not least, I also have an idle action, and I put it first so that it can be overridden. And I just say if Vy equals 0. I don't know, maybe I might set this to, I don't know, I think that's fine. We'll just say, maybe it should be both. I don't know, I'll have to think about that. But I'll just say if Vy is 0, if I'm not moving up and down. It might be a good idea to do sort of the opposite here. So I might do some testing. Like if the absolute value, instead of saying 0, maybe if I say the absolute value is less than 0, is less than 0.1. Just kind of the inverse of that. That way I'll get to idle a little bit faster. Might be good. We'll test it out. We'll see if it's bad. We'll switch it back. But that's basically the story, right? I'm just setting action to different actions when I press the keys, different arrays, and then I just animate action, and that just works so well. So let's just see how that looks. So there we go. You can see in midair I am able to do that, and I can walk forward just fine. I can walk backwards, literally walking backwards. I can jump, it lands, I let go of the keys, and the character just, sits there blinking wildly, and, we made it. Still needs to fix a problem though. The character is walking backwards, and that's not how Mario does it, right? Like when you go to the left, Mario flips. So the last thing to see is how do we get the character to flip around. So I have a piece of code here that I've shared on Teams. This is a reverse image function. It takes an image, and then it returns an image that is the reflection over the y-axis. So it's just flipped horizontally. So it's just the backwards image of whatever you send it. So you don't have to know how this code works, although you're most welcome to look at it and ask me questions about it. Just a quick thing for those of you who are curious. So we're using create image, which gives us sort of a canvas to work on. And then pixel by pixel, we are, accessing the pixels as an array, and we're just copying them over to the new image. So you're able to work with p images as arrays, and that's basically the story. It's kind of complicated, but and kind of out of the curriculum. So take a look at it if you're so inclined. But either way, you can get the code and then use it. So you can put it in like a utilities tab, and then you can use it for whatever you want. So now we would like to put in a direction for our F player. We need to know if we're facing left or right. So we're going to do that with a variable. You could do this a number of ways. I'm going to choose to do an int. I'll call it direction. And I'm going to assume that left is one number and right is another number. So I guess right will be 1 and left will be -1. I mean, you can choose. It doesn't really matter what numbers you choose. Should we put in some words for that? So I think left is actually already defined. Am I wrong about that? Yeah, these ones are already defined. So I don't know if that's if it's worthwhile to make our own sort of constants. But maybe I will anyways. I'll say final int L equals -1 and final int R equals 1. And I can just set things to L or R, even though, even though I'm just setting them to these numbers, just to help my code look a little better. So it should be the default direction that we face. Well, that's a good question. You can answer whatever answer you want. I'll set direction to R, I guess, as our default. Now, where this will actually matter is going to be in animate. This is where we will actually look at the direction variable and decide, are we going to make the image face left or right? So the only thing we need to do is just choose, do we attach the regular image, which is facing to the right, or do we attach the reverse? So how do I reverse the image? So I just call reverse image, and then I would send it this. And now it doesn't permanently reverse the image, just so you know. This will return a new image, and then we'll attach that reversed image. And you might think, wow, that's kind of wasteful, isn't it? Because we're doing all that copying from an array. And I can see an argument for that for sure, but I don't think it's too big a deal. It certainly doesn't lag out anything on our computer. It's pretty efficient to copy, these small 32 by 32 arrays of pixel data. But I could see if you needed to make this more efficient, this could be something that you might consider improving. And I could see different ways of doing it, but this is just a pretty convenient way. The code looks nice and simple. So I think we will make this slightly less efficient, but makes sense to code kind of solution. And if you're curious about a more efficient solution that wouldn't require us to be flipping arrays of data every time we're walking to the left, then definitely ask me in class and we can think about that together. Anyways, so how do we choose? We're not going to do both of these, right? We're going to do one of them or the other one. And it's just basically if direction equals left or right. So the regular ones are facing to the right. So I'll say if direction equals R, do this. And if direction equals L, then do that. And we could probably do an if else here, but I kind of like how that reads. It's pretty clear, you can see exactly what's happening. So next is when we actually walk left and right, we would have to set the direction variable, right? So A is to the left. So after I press the A key, I should set direction facing to the left. And if I press the D key, I should set direction facing to the right. Directoin. What's your favorite typo? Mine is flays instead of false. I always type in flays. Anyways, here we go. So I'm just changing the direction when I press left or right. And that's basically it. That's the story there. I could almost actually see having set these to A key and D key, whatever the integer values of those are, and then just, setting left and right to one of those. I don't know. I'm not too sure. But anyways, that's basically the story. So if we run this, we should now see the character flip. So if I walk to the right, things still work. But if I walk to the left, I set direction to L, or -1, and that causes it to flip. And you can see there's like 0 loss of frames. It's not struggling to do this. And it even works for like the idle costumes, right? Because once I press to the left, the character is still facing left until I turn right. So it's also flipped the jump, and it's also flipped the idle actions. So, I mean, it's just working. It's just working really well. It's not quite perfect. Like, I could see a couple of changes we can make. Like, it takes a while for Mario to go from, like, his jump to his idle. Like, it's just a split second, but it's noticeable. Minor little details like that, you know, I could imagine making some changes there. But, you know, for the most part, this is a great system that works smoothly. And our character is looking pretty dope. So that's how you can make a character animation, and I hope that you have success in putting yours together. In our next video, we'll take a look at enemies at long last. We will make the Goomba come alive. A Goomba will be a little mushroom dude or dudette who will cruise across the screen, and we can jump on them and crush them, but if they hit us from the side, then we are the ones who will be hurt. The classic Goomba is coming up. Thanks, everybody!